solve the following inequalities. So the absolute value of x minus 3 is less than or equal to 2. The absolute value of 2x minus 1 is greater than 5. And then C, 6 minus the absolute value is 6 plus 5 is greater than minus 2. So we're going to use two methods, an algebraic method and a graphical method for each one. So the absolute value of x minus 3 is less than or equal to 2. Now for the algebraic method, when x is 3, this bit will be equal to 0. So any value less than 3, this bit in the bracket here is negative, but we always need the absolute value to be positive. So the algebraic method, so for x less than 3, what we do is write down the function, but this time we put it in brackets, remove the absolute value sign and put a minus sign in front. And you'll see this when we sort of draw the graph in a minute, so I'll try to explain it then again. So then we've got to deal with that minus sign. So best thing to do is to multiply by minus 1, but when you multiply an inequality by a negative number, you must remember to reverse the inequality sign. If you multiply or divide an inequality by a negative number, then you must reverse the inequality sign. So this becomes x minus 3 minus 2. Then we add 3 to both sides. So adding 3 to both sides is going to give me x. Minus 2 plus 3 gives me 1. And then I've got my one part of the solution. Then we do it for x greater than 3. For x greater than 3, this just behaves as x minus 3 is less than or equal to 2. So we've got x minus 3 is less than or equal to 2. If we add 3 to both sides, we're going to have that x is less than or equal to 5. And then x has to be bigger than 1, but less than 5 is the answer. Now, we can see perhaps why we do this when we sort of draw the graph. So the graphical method, first of all, we'll draw the graph of y is equal to the absolute value of x minus 3. So the crucial point is this one here at 3. So we'll mark that on. Now, when it's positive, it behaves, for every one it goes 1 up. And if you extend that backwards, that would go through the point here, minus 3. But this bit here, if it was a straight line, would get reflected. So it goes up here, like that. So this is 3. And therefore, that is the graph of the absolute value of x is minus 3. And then we wanted to know where it's less than or equal to 2. If we draw the graph what y is equal to 2 on my graph, where is this graph less than this graph? That's for all these values. So that's from values of x from here to here. So we'll mark those on from 1 to 5. So x, the absolute value of x minus 3 is less than or equal to 2 between 1 and 5. Now you can see why perhaps now you do minus for values less than 3, and then positive for values greater than 3. So this is quite important for the algebraic technique. So again we get the same answer, x must be between greater or equal to 1 or less than or equal to 5. Part B. The absolute value of 2x minus 1 is greater than 5. Now what will make that 0? Let's pause the video for a little minute. We can see that x is equal to a half. We'll make that equal to 0. So for values of x less than a half, we have to do minus 2x minus 1 is greater than 5. If we multiply by minus 1 and remembering to reverse the inequality sign, we get 2x minus 1 is greater than minus 5. If we add 1 to both sides, we get that 2x is less than minus 4. Dividing by 2, we're going to get that x is less than minus 2. For values of x greater than a half, this is positive, so we just solve 2x minus 1 is greater than 5. So for plus 1 and plus 1, we're going to get that 2x is greater than 6. If we divide both sides by 2 here, we're going to get that x is greater than 3. Right, so x is less than minus 2 but greater than 3, so we can't join the inequality up here because x is less than minus 2 or x is greater than 3. So we have to separate the inequality with an or sign or union if you're using set notation. Now the graphical method. So first of all, we'll draw y is equal to 2x minus 1. So drawing that, the critical point being a half, so put that point on first, and then I'm going to put -1 on because this is 2x minus 1, and that means for every one along I go 2 up. So another point will go here, and the next point will go here, and they will carry on in that pattern. And then going this way, for every one along, we're going to go up here. Sorry, I'm just going to change that. At -1, that point will go to there, and then for every one along, we're going to go 2 up. So we get the pattern like that. So you can sort of get that V shape again. Label your graph. We need to put on the graph of y is equal to 5, which is there. Okay, where does it intersect? Here at -2 and here at 3. So notice we're going to get the same sort of answers here. We wanted to know where 2x minus 1 is greater than 5, so it's greater here and here, so that's going to be less than -2, and open circle because it's not equal to, or greater than 5. This graph will be more than this graph. That's what you're asking when you're using the graphical method. So again, it gives the same solution, that x is less than -2 or x is greater than 3. Finally, you've got 6 minus the absolute value of x plus 5 is greater than -2. I'm going to rearrange that a little bit. If I take 6 from both sides, then I'm going to get minus the absolute value of x plus 5 is greater than -8, and then multiply through by -1. I'm going to get the absolute value of 5 is less than, because you have to reverse the sign, because you're multiplying by a negative number, than 8. And now I'm going to solve that inequality using the algebraic method. So the critical value is going to be 5, because -5, because that was what will make that equal to 0. So for x less than -5, I'm going to solve minus x plus 5 is less than 8. If I multiply both sides by -1, x plus 5, and remembering to reverse the sign, so reverse the sign, we're going to get x plus 5 is greater than -8. Subtracting 5 from both sides, we're going to get that x is greater than -13. For x greater than -5, then we just consider solving x plus 5 is less than 8. Taking 5 from both sides, we're going to get that x has to be less than 3. Now for the graphical method, so the answer will be x is greater than -13 and less than 3. Now using the graphical method, we're going to need quite a long x-axis here, because we're going to leave from -13 to 3. So draw yourself quite a wide x-axis and a y. Critical value was 5, and then what I'm going to graph is this one. Y is the absolute value of x plus 5, and y is equal to 8 on the same graph, rather than trying to draw this one. So the critical value is -5, so mark on -5 on your graph. So we're going to draw those two graphs. Mark on -5, and then it's y is equal to x plus 5 will be every one along, one up, every one along, one up. So that graph will go like that. This point will be 5. Okay, and then going backwards, if that continues down, that gets reflected up, and sort of the pattern goes backward like that. So we get that V shape. Draw on the graph y is equal to 8, so that's going to be there. Draw a nice straight line. We're interested in the points of intersection, which is going to be there. That gives me -13, and there, which is 3. Now, we wanted to know where x plus 5, this is the inequality we're considering. X plus 5 is less than 8. It's going to be less than 8 here. Okay, so it's going to be everywhere between -13 and 3. So x will be greater than -13 or less than 3. Okay, so just a little point then, when you're doing the algebraic method, you need to find the value that makes this equal to 0, and then for values less than that value, the thing acts as negative, and for things greater than that value, the thing acts as positive. Okay, so this has been a video to show you how to solve inequalities using both an algebraic method for the modular function. I hope you've understood, and thank you very much for watching.